happy to be here. Thank you to Renata for framing the conversation. I'm very excited. I work with the Open Knowledge Foundation as well. I help lead something called the AI Learning Labs. But like Renata, I've been in this field, general field, for many years. And I'm always curious when new technologies come up, how regulators respond, how civil society responds. And I'm very eager to hear from the panelists that we invited today. It's folks who are at the heart of building, actually, technology, both neurotech technology, also privacy-preserving technology, people who have different vantage points of understanding and ability to explain how the tech works, how community innovation works in this new ecosystem, what we can learn from the past and what we can hope for the future. And I wanted to start by inviting Zoe Steine-Hanson, if you want to turn your camera on. She's a research scientist at an organization called OpenBCI that is working precisely on open hardware, open software issues. Yeah, I mean, cameras, you can turn the cameras on if you want. It's nice. The rest of the speakers, or you can do it one by one. You have freedom to choose. But Zoe, I wanted to ask you if you in a few minutes could explain a bit about what you do at OpenBCI, and help us understand what is, when we think of the tech stack, like we talk about it in a lot of different contexts, what is the tech stack for BCI technology, brain-computer interface? How do you think about it?
Great, yeah. I have some slides, so I'll see if I can present those to kind of help. Oh, how do I do this? Or that's okay. I'll just give a little bit of a background about myself, so that everyone kind of has an understanding of the perspective of where I'm coming from as I talk about these things. And
I just gave you
Oh,
presentation access now.
Okay.
Yeah.
Let's see if I can figure this out.
You should have a button now.
Okay. Maybe I'm not seeing it. That's okay. I know the content and I can talk through it, and hopefully without images is totally fine. But yeah, thank you guys at the Open Knowledge Foundation for inviting me. I'm happy to be here and chat kind of about my experience and where I am in this technology stack. So for context, I am a research scientist at OpenBCI, like Solana said. Before that, I did my PhD at the University of Washington in computer science. And before that, I did my undergraduate in computer science as well. So I'm purely a computer scientist who somehow ended up looking at brain data every day. And while I was in my PhD, I also did a stint at Meta Reality Labs and helped contribute to that neural band. So just another type of kind of brain-computer interface or a neurotechnology that's out there that some people might be familiar with. And so when I was in my undergraduate degree, I was working in a human-computer interaction lab. Specifically, I was looking at gender biases in software at that point in time. And all of that was really interesting, but I ended up taking a psychology class that was focused on brain and behavior. And then I was like, the brain is so interesting. I want to know more about that. How do I use my computer science knowledge to make sense of what's going on in the brain? And so that's how I ended up getting into the BCI space. And, 5 years later, got a PhD and now work at a amazing company called OpenBCI. And so OpenBCI, the mission is centrally is to have open source technology available in this space. So especially for like our Cyton and our Ganglion boards, all of that is, you can get, again, I'm not an electrical engineer, but if you know how to read, chip diagrams and all of that is available, and people can make modifications if they want to. The code is also available as well, including the firmware code and, you know, higher up in the software stack as well. So that's that has been the core of what OpenBCI has been doing. And then interestingly, I actually work on another one of our products primarily, which is the Galia headset. And that is a fully integrated headset that includes EEG, EDA, PPG, eye tracking, just kind of anything that you can get on the head is pretty much included in that headset. And that particular device is actually closed source. So it's kind of interesting to see, even in a technology company that is really motivated by this open source concept. You know, at the end of the day, all companies still have to pay their bills. And so that's why we kind of have these two tracks of products that exist in our world. And so I, as a research scientist and as somebody with a large data science and machine learning background, spent a lot of time working with that Galia headset. And so kind of one of the reasons that we are interested in doing that work is because all of our bodies are creating this ocean of data as we are, you know, moving around and talking. Our brains are firing, our muscles are firing, our eyes are moving around. All of that is information that we can potentially leverage. And so that's kind of the main motivation behind most BCI technologies, is how do we leverage all of that information that's happening in your body all the time and turn that into something potentially useful. And so there's kind of two different ways that people approach this. At OpenBCI, we mostly work in the like reading side of things, but there's also, I'll give just like a little tidbit about people also doing like writing or helping to modulate the body and the brain. And so that's things with like neurostimulation or other types of stimulation. That's not my field of work, but if people are curious about that, that's kind of another track in the BCI world. But ultimately, I think a lot of people in this space want to build these like closed loop systems. So things that can both do the writing or the reading part of the body and then also writing to the body. So, you know, potentially being able to say like, okay, it looks like this person is, you know, really stressed today. Can we do a little bit of stimulation to help reduce that stress? And so that's like one particular area that I have been working in, is kind of those types of closed loop systems. And so, you know, I think one day we'll live in a future where that's a little bit more common. Of course, with especially with the writing back to the body, there's a lot of neuroethics questions about autonomy and things like that. So happy to chat about that as we dig into the panel. But yeah, that's a little bit about my background. Yeah, working on kind of these closed loop systems, doing a lot of data analysis and a lot of machine learning in the work that I do.
Thank you. Thanks, Zoe. That was a great introduction to the work that you're doing. I can't wait to ask you questions in a moment. I spent some time looking at the OpenBCI website ahead of this summit, and I mean, on the blog, and for those of you who haven't maybe visited the site or know what the project is, on the website, there's like all these people, students, young people, different people who are bringing this like very open hardware type energy to their projects and are documenting the things that they're doing using open hardware from OpenBCI. And it could be like, there was one guy who was making a tool for his dad who has Parkinson's to be able to move limbs that he's lost control over. There are people that are playing with robots, experimenting with things, asking questions about how do you attach these devices to animals. I mean, and that's just in the last couple of months. So there's a lot of energy around this right now, and I think, you know, it's still a new topic for the Open Knowledge Foundation and the open knowledge communities, but it's exciting, very interesting to see the type of innovation and the sort of projects that are coming up around this topic. I'd like to welcome to the floor panel Christoph Guger from g.tec, who is also working very directly on both the technology and the business of neurotech and has been working on this topic for many, many years. I'm so curious about your journey in this world and where you think it's headed. What I was also interested to see, looking at your company and researching some of the work you do, is also that you have this enormous company and have worked with really huge, big companies across the tech ecosystem, but also that you organize community events and hackathons. Yeah, I'm curious about that contrast and how you're thinking about open from your vantage point.
Thank you very much for the introduction. I see now a little plus in the user interface. It's telling me, should I upload the presentation? Do you know how to share a screen? Or should I press the button?
You should have a button beneath the screen. Near where the little camera is. You definitely have
the button is missing. I only have the plus to upload a presentation, but I guess that's not what it should be.
If you want, you can send it to us and we can put it in the screen.
Yeah, I'm just jumping in. I'm Lucas from Knowledge Foundation.
Hello.
You were set as a presenter now, Christoph. Same for Zoe before. So in the buttons beneath your screen, like should be like the microphone, camera, and then the screen sharing button probably.
Yeah, I see the camera and the microphone, but I don't see the screen sharing.
Oh, that's weird.
Maybe now I got it.
But you can please email your presentation.
I found it. It was just.
Oh, you found it. Okay, that's great. So you're all set. Yeah.
So let's move that.
It works.
But probably coming. Yeah.
We lost Christoph.
I have you again, I guess. Do you hear me?
Yes, we hear you.
Do you see the screen?
No, we don't see you either.
Yeah, maybe we forget the idea with the screen sharing. So I activate the camera.
So sorry for the technical trouble.
I think we lost also the camera, so you can enjoy my voice and accent. So I give you an explanation. We started about 27 years ago with g.tec. So I was studying at Johns Hopkins University, and at this time, and then I got EEG data on a music tape, and to read it into MATLAB, I had to digitize it first to be able to compute the EEG data. So this was the status 1995 magnetic music tapes. And then at Johns Hopkins University, they told me about the Professor Gerd Purcell. Yes?
Christoph, do you think you could try activating your camera?
It doesn't allow me. If I press the button, it's saying...
There you are. Yeah, I'm sorry. Yeah, it's much better when we can see you.
So at Johns Hopkins University, they told me about a professor in Graz in Austria, Gerd Purcell, and he was one of the three pioneers in brain-computer interfacing. There was John Wolpaff in New York, in Albany, Bierbaum in Germany, and Purcell in Graz. And he developed a concept that was called event-related desynchronization. So you could basically move a cursor left and right with motor movement imaginations, left-hand, right-hand movement imagination. This is also what people wanted to do 25 years ago with brain-computer interfaces, to move a cursor around brain-computer interfaces, and the EEG hardware is locked. So basically you didn't have access to the data. So mostly clinical systems at this time existed, and they were really big. So we started to develop our
We lost Christoph again. I wonder if it's an internet connection issue. Could be. Okay. Ah, you're back. Hi, Christoph. Welcome back. I think your audio is warped now. I wonder if you might be having connectivity issues. Could you try, refreshing? We can't hear you. Okay, I muted Christoph for a moment. Christoph, could you try refreshing one last time? And then, hi, Christoph. I'm still hearing a strange sound. Is your video working?
What's about now?
Now the sound is great. We just need the video.
Hello again.
The sound is great. We hear you. Do you think we could have a camera for you, Christoph? Okay. Unfortunately, your sound is bad again. Sorry, we can't hear you. Yes, I'm not sure exactly what to suggest. Maybe there's a different internet connection you can try. Yeah, it's not working.
Excuse me, may I jump in here again? The buttons below, there's like the mic, the camera, and so on. There's like a small arrow where you can set what's your microphone. You probably know that. So there, when you open it, it's quite straightforward. You see microphone and speaker. So one of your mics is working. So we need to figure out which one. We'll try, playing with those, like, selecting each of those, and then the audio will come.
Maybe this one?
No, this one. Yeah. So yeah, we probably found it. And same for the screen sharing. When you click on the screen sharing button, that you probably see there because you see your presenter, it will ask you like what window or full screen you want to share. Yeah, so now we can see your screen. That's perfect. Great. So you're all set.
Can you hear me?
So better now. Yeah. Thanks. Sorry for bothering. And sorry for technical issues.
Yes, we can hear you, and we can see your screen. And because I should say though, because we lost a bit of time with the technology, if you're able to maybe zoom past some of the first the first slides, or do an abbreviated version, so we manage to.
I do it very quickly, okay? So
yes,
we are internationally active, and about 1999 we designed our first brain computer interface, and we just made it much smaller. So this mobile app was, for example, the first wireless system on the market, which had an application programming interface. This allowed all the brain-computer interface researchers to read out the data in real time, sample by sample. This changed everything because suddenly you got access to the high-quality data. And here you can see, for example, an amplifier that we built in the year 2000. So this was the amplifier used for the first invasive brain-computer interface experiment. Later on, we built wearable technology to make it much easier. In 2017, we started also with a Brain IO hackathon. So in this case, we are taking care of students, developers, biomedical engineers, neurosurgeons. So they are all participating in these hackathons. And over a weekend, they can actually learn brain-computer interfacing. They can design their own applications. And nowadays, it's amazing how far they can go within 24 hours. So last hackathon had more than 1,000 people attending from 140 countries around the world. So it's getting bigger and bigger. This can be explained by easier tools to use. So 3 years ago, for example, we developed a Unity interface. So you're getting all this BCI data into Unity. Then you can design your own computer games without understanding the BCI technology per se, because this is all pre-programmed. Then we have also a couple of medical products. So I mentioned one. This is, for example, Cortec-Q. It's used by neurosurgeons to figure out where the most important brain centers are located. Then it's, of course, FDA cleared under different medical regulations, like in Europe. And then it's closed, of course, and then you're also not allowed to change anything because you don't want to risk the patient anything. And late last year, we developed also g.tec to bring Python into neuroscience. This is used by many, many programmers around the world nowadays. With this g.tec, you can set up a fully running BCI pipeline within a few hours, and this makes it even easier. But for all these things, data quality is super important, and I'm just demonstrating here what I mean with that. This is Martin, a very good computer scientist, and he's doing different exercises. And on the left, you can see a 8-channel EEG recording. And on the right, you can actually see the output of our Unicorn Hybrid Black after all the signal processing that we are doing. You can see that the tasks are getting more and more difficult. So now he's doing sit-ups. On the left, you can see there's a lot of muscle contamination inside the EEG, which makes it really difficult to interpret the EEG. On the right, you can see we still have clean EEG data. Let's scroll a little bit forward to save time. Now he's making a handstand. So on the left, you can see that the EEG is completely blanked out by muscle contamination and by movement artifacts. On the right, we can still see nice EEG data. The last one is a backflip. So you have to watch carefully because it's only lasting like 100 milliseconds. So he will jump very soon. In 2 seconds, he jumps. Watch carefully. So we get huge movement artifacts here on the left. On the right, we have clean EEG. This is changing everything where you can use BCI technology nowadays. And one of these applications, it's a medical application, is Recoverix. This is what we use for stroke, multiple sclerosis, and Parkinson to make patients better again. So the training is done with left-hand movement imagination. The brain-computer interface picks it up that the sensory motor cortex is activated, and then we stimulate the left hand so that the hand movement is really done. The right hand is actually the paretic hand, where the brain was damaged because of the stroke. He imagines the movement, the fez stimulates the hand, and you can still see in the index finger the spasticity. These patients are doing in total 6,000 movement repetitions, and afterwards they just have better hand movements. So here's an example of one stroke patient. On top you can see the 9-hole peg test before the Recoverix BCI treatment was done. In the middle you can see a video after 25 treatments. This means that the patient was treated for 18 hours. And on the bottom you can see it after 36 hours of treatment. You can see the hand movement is very nice. Fast, smooth movement. Actually, I wouldn't see anymore that this is a patient. When he removes the pegs, it looks completely normal. And if you go now back to the video before the treatment, you can just see how much more difficult it was before. So this is what we can achieve nowadays with brain-computer interfaces. And very important is also to have access to these data sets, because then the community can just make BCI systems better. This is something that we are providing, for example, in the hackathons. So there's always a big challenge ongoing to make the signal processing better. We started also just around Corona with the Brain-Computer Interface and Neurotechnology Spring School, where we invite around 100 keynote speakers from all around the world to present for 1 hour. So we have Stanford, Harvard, Johns Hopkins, big companies all around the world. It's for free, and it lasts 140 hours, 10 days long. And last time we had more than 90,000 people joining Spring School, and I was also mentioning the hackathon, more than 1,000 people in the hackathon. And it's amazing how much progress these people are making. So many years ago in the hackathon, they didn't achieve so much, but nowadays, you know, everybody gets a real-time brain-computer interface running. And this is exactly what we want to have. And with that, I end my presentation. Thank you very much.
Thanks so much. I wonder if you could say something about openness and how you are thinking about openness in the context of your work.
Yeah, we are providing for all our biosignal amplifiers and brain-computer interfaces, application programming interfaces. This means you can access the data directly at the hardware sample by sample as fast as you need it. But there's of course a limitation to the openness. The headsets, the firmware on the headsets not open because it's pretty complicated. In our g.tec, for example, we have 100 man-years of development inside. And if somebody would touch the firmware, it's very easy to destroy it. So it wouldn't work anymore. And then you get also other implications. You need electromagnetic compatibility testing for all different countries around the world. So you have to show that your device is not radiating electrical fields and disturbing devices in the neighborhood, but also in the other direction. It's not allowed that your device crashes because there's something disturbing in the neighborhood. And these regulations are really tough. So by touching the software, you would destroy it, and then you would have to do all the electromagnetic interference testing again, which is a lot of work. It's really expensive and it's also dangerous. So there's a limit where it makes sense. But if you are getting the data sample by sample in real time, it's completely open and you can use it, and it's still medically certified and tested. And for data sets, you know, data sharing is super easy. We store, for example, all the data in MATLAB in the HDF5 format. So it's very easy to read it into Python and many other programs. You can also transform the data format into other formats. We have also a server where the data is stored, where you can access. And then you can run your own scripts, program, for example, in Python. But we have also ready-to-go scripts. And normally researchers, you know, they use the ready-to-go scripts. That's proven, it's tested, it's validated. They don't have to worry about that. So they do a couple of processing steps, and then they can always add their own fresh new algorithms to extract something in real time, to do offline processing. So this is a very healthy handshake of different principles.
Great, thank you so much. I want to bring the third and final person to the conversation, Harry. Harry Halpin, thank you for your tech support in the chat. If you want to turn your camera on now. I'm very curious to hear what you'd like to bring to this conversation. Harry works on at an organization called NIM, building decentralized tools to end mass surveillance, also currently known as a VPN. But you are an expert on web cryptography, also on AI, also on different open standards and ways of regulating and ensuring that there is accountability in the tech stack. And so I'm curious, we didn't mention the word accountability so far. We heard about openness and how it helps with innovation, creativity. What are you worried about when you hear about neurotech and the types of things that are possible?
So I think, so my background is in standards, particularly web standards and open data standards. So open data is obviously very important for brain, computer, and human interfaces. Now the problem with a kind of naive approach to open data would be that this is very private data. To some extent, it's close to medical data. And so you don't want, for example, Neuralink scanning everyone's brains and releasing that data on the open internet to comply with open data standards. At the same point, you also don't want Neuralink to be scanning your brain data, and then they own that data and you have no access rights and you cannot get them, for example, to remove it like you would under GDPR or California's consumer privacy regulations or whatever local variant you have. So I think, one question is, given it's very good to have open hardware and open data in the space, but you can't forget kind of user or consumer privacy. And you need to have some kind of both technical and ideally regulatory, although good luck with that one with Trump, way to kind of hold these companies into account. So that's kind of the nature of the accountability. How do you know that the companies are not abusing your neural data? How do you know they're not using algorithms without your consent, trying to predict your behavior, trying to control your behavior? Because it could literally lead to forms of both collective and individual mind manipulation. Obviously, mind manipulation has been done through various soft technologies for many years, everything from the radio leading to fascism, to television, and then of course now algorithms on the internet controlling people's feeds. But these are all very soft compared to the amount of data that could be collected with brain computer interfaces and the amount of control. So if people say, well, don't worry, the company won't do that, but companies have to do that because under capitalism, companies have to make money. And one way they make money is by shortening the time of reaction from what they need, some sort of ideally advertisement, to like say purchasing intent or other forms of actions that they want you to take as a consumer, as a user. So it's a very dangerous space on that level. And so you will need some form of privacy, both on the technical stack and on the standard stack. So you can't just put everything in a database and expect everyone to be nice. So I think this is a real danger of this technology. Now, luckily, we have some lessons that we've learned over the last 20, 30 years of watching the web mostly go wrong. So things that we've learned is that governments do not regulate very well. If they do regulate, they will often, companies will ignore the regulation and will just suffer the fines. So if you tell a company, we'll give you millions of dollars of fines unless you don't do this thing, but the company can make tens of millions by doing this illegal thing, they will do the illegal thing and then pay the fine. It's quite logical. So we saw this a lot. You cannot just have the user signal their intent. If I'm a user and I want to, let's say I don't want to be tracked by cookies. When I was working with Tim Berners-Lee at the World Wide Web Consortium, we had this standard called do not track. So the web browser would tell a web server, please don't track me. And what happened is that standard was killed, mostly by large advertising companies and firms like Google, but also you just tell the companies you don't want to be tracked, they're just going to ignore it. Or they'll make it impossible for you not to be tracked. So you see these very annoying GDPR-based kind of pop-ups where you have to click consent to being tracked. And there's really almost no way to not consent. So we don't want brain interfaces, which have much more sensitive data than web surfing, to enter this same kind of bad situation. So I would recommend looking at cryptography and looking at user control of the devices and explicit sort of data tracking and provenance standards. So what you want is you don't want the data to be accessible to anyone but the people that have access to it, which you've consented to. That access should not be enforced by rules or goodwill, but should be accessed by cryptography. So cryptography is what allows you to encrypt data, so it's confidential. and then lets the data basically only be decrypted, which is put into clear text or made usable by those who are given access. So we do have, although not a lot of research in this space, but we do not see much of it deployed. And so obviously any brain and computer interface would have to have some level of encryption. The other thing we might want to point out is encryption is only half the problem, because even if the data is encrypted, the use of the data, who's talking to who, the transmission, the time it's taken, the volume of data that's being taken, this is all observable even when the data is encrypted. So that's why I recommend also hiding the metadata. That's the kind of time and place and characteristics of the data itself. That metadata can often be more important than data, particularly for behavior prediction, which is one thing neural technologies will certainly be used for. And for that, my company, NIM Technologies, NYM, we have a thing called a mixnet, which basically takes encrypted data, mixes it up like a deck of cards, and then so someone who's watching the data doesn't know where the data is coming from, and only the people that you've authorized that the data can kind of put the cards back together and then decrypt the data. And so I think the combination of privacy enhancing technologies based on encryption and mixed nets with some form of metadata control, mixed with classical, what you call access control, who has access. And every time there is an access to data, recording some provenance would be good. Now, it would be nice if governments made that mandatory. I'm a little bit doubtful there, given the shambolic state of most governments right now. But nonetheless, consumers, you had to choose between, let's say, Neuralink or Neural's super invasive technology, which who knows might let Elon Musk control my mind. That would be kind of terrifying for many people. And if there's a privacy enhanced alternative, something which let me, for example, sample my own brain data and then let me give that to my doctor, but wouldn't let necessarily have to go through a bunch of servers controlled by some random company, that would maybe be more successful in the market. So I do think there is a case both for standards and for letting companies adopt the standards and push other companies to adopt the standards. And of course, governments should regulate, but we can't guarantee that. That's the easy way out. We have to build both the open and the privacy enhancing technologies. Otherwise, it would be quite dystopian if the current kind of surveillance apparatus that we see controlling most of the internet, moved into our physical brains. I think that would be quite spooky for most people, including myself. So I think that's about it. I'm happy to talk more or answer any questions.
Thanks so much. That was very helpful in terms of a framing and getting us thinking about what are the risks and also what are the opportunities to actually think constructively about how to solve it and still be able to do stuff with this technology. Zoe, I'll turn to you because you're the one who said that our bodies are creating oceans of data that is waiting to be leveraged. And when I hear the word leverage, I also get like, what, leveraged? How? For what? Is it because you want to make money off of me? I wonder also if I could just like ask you a really basic question in the context of like responding to Harry and to me. How unique is my neuro data? Like if I do a backflip, like the guy in Christoph's video, will my neuro data look the same as that man's, or will it look totally different and unique to me? I think the type of thing I'm sure you know that people are always wondering about is like, can you read my mind? How deep or how much is possible now versus our imagination of what might be possible in the future.
Yeah, those are great questions, and I'll answer your second question first. So for one, I will give the caveat, like the stuff that I work on, we can't quote unquote read your mind. Not in the way that, when people are thinking about it, they're thinking, oh, I'm thinking about my dog and you're going to be able to tell that exactly I'm thinking about my dog. There are some technologies, especially invasive technologies. So Harry mentioned Neuralink. Neuralink is an invasive technology. Those tend to be closer to kind of that. And people have been doing a lot of work in terms of like brain or like neural data to text data. And there is, yes, exactly. Invasive means that something is implanted. And you get surgery done in some way or another to have that actually implanted into your body. So there is, you know, for various reasons, the signal quality is better in invasive technology. So it's easier to do this like brain decoding, mind reading thing. And there are companies that are doing the same thing in non-invasive technology. So OpenBCI is a non-invasive technology company in the brain-computer interface space. So we only build things that are kind of like wearables. So kind of like my, you know, fitness watch, you put it on, it'll record things while you're wearing it. But obviously when you're not wearing it, it can't pick up those signals anymore. And so there are companies that are working on that same sort of like neural data to text sort of setup, which is what most people think about when they think of like, oh, technology is going to read my mind. I don't know. Well, you might get to a point where you can do that with the non-invasive technologies. I think we probably will eventually. I don't know how soon that'll be. But that just kind of gives a sense of the landscape. I think eventually that'll be possible, but I also think there are certainly people in the invasive space who think that everyone's going to have an invasive implanted BCI eventually. And I personally am not a believer in that, because I think that the non-invasive technology will get to a point that it'll be just as good. And if that's the case, then, you know, there's at least maybe a little bit more freedom in terms of us choosing when we don't wear those technologies. So that's kind of just my point of view. I know there are certain people who are like, oh, but the signal is better for invasive technologies, which is true. But the risks are definitely much higher, and the privacy concerns, I think, are much higher for an invasive technology like that.
And what about my back flipping? Will it look the same?
Yes. It will probably look similar. So there is a whole line of research in terms of identifying individuals from brain technology, and that there's, you know, if you search like identification from EEG, you'll find a slew of papers on this space. So everyone does look pretty unique in their own ways. But there are also going to be overlying similarities. So if you also did a backflip, it would also still look quite noisy. It wouldn't look noisy in exactly the same way, but that probably would have more to do with how you did the backflip and the types of motion artifacts that you generated, rather than something about your specific neural signal. But I'm sure that Guger would have other opinions, maybe have other thoughts on that.
Yeah, Christoph, would you like to come back with your camera? I'd love to include you in this part of the conversation too.
I guess I'm back.
Yes, you are back. Yeah, so what is your reaction to this in terms of the data that's gathered about people? How are you thinking about protecting people from companies that are overreaching or governments that are overreaching? Is that a concern of yours?
Of course, and there are very tough medical regulations already in place, FDA, MDR, and all the others. So medical regulations are stricter than aviation. This means a medical product has more regulations than a Boeing or an Airbus, for the simple reason that patients are already ill and you don't want to put them at risk just because the device is not good enough. So first of all, people have to start to read medical regulations and meet it. So there are many normatives on cybersecurity and much more. So we have to follow that. And so there's already a lot of things are done. Then it's, of course, depending on the application. Of course, there's a discussion between invasive and non-invasive, but it's, again, depending on the application, what you want to do. If non-invasive or invasive is better. If I think of a paralyzed person where you want to control the exoskeleton, then an implant is, of course, the way to go, because it's permanently implanted. The person can use it all the time. With an non-invasive brain-computer interface, you have to put it on, you have to calibrate it all the time, so it's too much work for daily use. But other applications, like for example a communication system where completely paralyzed people can communicate, is completely fine with non-invasive technology. Stroke rehabilitation is completely fine with non-invasive technology, so I don't need more resolution for doing this. And people are still improving 10, 20 or 30 years later on. So it's very much depending on the application, what you choose. In Canada, we have, for example, a client, and they use non-invasive EEG to detect concussion. So they have a lot of hockey and rugby players, or foot soccer players, and very often they develop a concussion, but you wouldn't really see it. And with ERPs, evoke potentials, and EEG technology, you can figure it out after a few minutes. So in this case, it's very useful to be aware that you had a concussion as soon as possible so that you can do appropriate interventions. But of course, you don't want to have this data in wrong hands, that you're having now a concussion. So this must be controlled, but it's anyhow done already in hospitals. It becomes, of course, different if you're putting the data on a server and everybody can analyze the data on the server, so access must be regulated. For our stroke rehabilitation data, it's, for example, very interesting. If we just acquire a few minutes of resting state EEG, we can predict how much better the stroke patient will be after recovery therapy. And we can also quantify how much healthier the cortex became because of the neurorehabilitation BCI therapy, because of producing neuroplasticity. So if we put, for example, all the data on a server and we analyze all the patients that we had, and just in our own center, we did more than 30,000 treatments. So we have plenty of data. Then we can get smarter and smarter. And there could be a good biomarker predicting, for example, dementia. So in the future, there could be an email sent to the patient, hey, be careful, you are developing a dementia, do something. So it can be very useful, but of course it must be controlled.
Well, yes. I mean, I also think of all the terrible things that could happen with that kind of data, because you could also, I mean, you could be communicating with the patient, but you could also be communicating with their health insurance company and telling them that the patient is not worth insuring anymore because XYZ is likely to happen, or false positives, or, I mean, exactly what you were saying, all this information in an Excel spreadsheet. I mean, the numbers that you're talking about right now are in the tens of thousands, but then when we imagine this kind of data gathered at a mass scale, you know, assuming that BCI devices become, you know, normal, right? Like, what if it's the new way to talk instead of a smartphone, or the new way to control your TV, or if we start gathering data from hundreds and thousands and millions of people around the world, brain data, and then inferring things about their behavior or their health, I mean, surely that is something we should be worried about now.
Of course, it must be taken into consideration, but also, you know, a health screening, an EEG health screening, like you're doing a full body heart screen, for example, all around the world, doesn't exist yet. So a brain screen makes fully sense to have early interventions, and if insurance companies are adapting to that, and maybe it becomes a requirement beside, you know, your healthy screening, to have a brain scan. I think this will become normal, and insurance companies, why not? They can be informed about what you are developing, so they can also have a better health financing system by reacting on it. So if they figure out that more people develop dementia, they have to find solutions to help all these patients in future. So it can also be very positive. And normally, you know, companies are not looking for unhealthy employees. So this is, nobody wants to kick employees out because they develop something. That this is not what's happening, at least not in Europe, because then the health system is anyhow taking over the health costs for the employee. So nobody fires an employee because he has a concussion or develops multiple sclerosis or whatever. It's not happening here. But there can also be a lot of positive things if you have this information. And many people talk about mind reading. You know, you really have to calibrate the brain-computer interface on certain tasks that the system should read out. And very often this is limited. With implants, language reading or silent speech decoding works fantastically, but it's used in patients who are completely locked in, who cannot communicate. Of course, then you get ethical questions like, are they allowed to make end-of-life decisions? But this has to considered by different countries. So Switzerland, for example, is very open for that. In Italy, this conversation is a no-go. There is no end-of-life decision for patients. So this is up to politicians and the governments what they decide. But of course, it's very useful to have this type of technology. We have, for example, a brain-computer interface that we use for patients with disorders of consciousness. So these patients are in the hospital for many years and nobody has an understanding if they can follow conversations. This means family members are coming maybe for years and they are talking with the patient and they never get useful feedback. They just don't know if the patient is understanding them. And with BCI technology, after a few minutes, we have an objective proof. They can say yes and no with the brain-computer interface, and if they answer most of the questions correctly, we have a very objective proof that they can follow conversations. And suddenly it makes much more sense that the family visits every day. The doctors are more motivated because they know the patient is understanding it. But also the opposite is very useful. So if the patient has no awareness, no comment following, then it's maybe not so useful to spend every single day 2 hours in the hospital.
Thank you. Harry, you made the comparison earlier between web technologies and I think also, you know, the surveillance capitalism. You didn't use those words, but I guess, you know, the collection of data, for instance, for advertising, makes me think of data brokers, makes me think of data collected from a lot of sources that are used for different purposes that we aren't always able to give consent to. Like, we don't know what our online profiles look like once they end up in the hands of different companies or in different countries. I'm wondering, because there hasn't been a good track record in terms of regulating the web or like protecting the rights of consumers, maybe in this context, like how much do you think that there could be a technological way to make people feel safer as these technologies evolve? You know, how much is it this question of giving the user more control over their data and how it's used? How much is that a technical question and how much is that a regulatory question?
Yeah, I mean, I just want to respond a bit. It's all ultimately a social question, but the social question can be usually enforced by regulation and technology. We have seen, at least in the case of regulation, a lot of failures in terms of privacy. We've seen very few successes. And technology that can enforce privacy is typically not deployed or under-deployed, despite the fact that it exists. So you do have technologies which can do perfectly good encryption and tracking and access control, and even metadata reduction via mixed nets of any kind of data, including medical data, but very rarely is this data used, despite being often even recommended in the regulations. Now, I would say that I just want to be clear, I enjoyed Zoe's point, but there's not a huge difference if the data is coming from an invasive source or non-invasive source. And the reason, you can just look at like other wearables, right? So you look at Garmin watches versus Whoop, which is the health wearable very popular in the US, versus the Oura rings. In general, you do need some form of open data standards, data control. All of these aforementioned companies, I mean, not OpenBCI is obviously doing the right thing and is a good company trying to do the right thing in a good way. But if you look at like the large, very lucrative wearable market, Almost all the data stored in proprietary formats cannot be transferred between devices, cannot be in any meaningful sense controlled by the user, is being gathered, and is, despite being maybe not particularly accurate, could be user behavior prediction and control. That's like why they're gathering it, right? I mean, and the reason what should be interesting, what you have to remember is even if the BCI data appears to be harmless or very low resolution by itself, it does not necessarily mean that combined with large machine learning, which you may call AI if you were so inclined, algorithms that can be combined with other sources of data, right? So, your Garmin, for example, will follow your heart rate, which will follow your geolocation, which will also tell Garmin where you're shopping, all sorts of things. Data can be combined from diverse sources. And this could be good. So, for example, in medical cases, we probably do want, for treatment, and this is to respond to Christoph's point, we do want to have different forms of data, ideally mixed up. This will probably lead to new kinds of treatments, can very much help people, help patients. But then it can also, if that data is just controlled by random companies in a black box format, that's quite dangerous. And you have to be aware that while there are countries where there are very strong medical regulations, I'm familiar mostly with HIPAA, but Canada and Germany, I would assume, have quite strong and strict and probably mostly followed medical regulations. There's a trend. You can look at these kind of islands various companies are buying for medical experimentation. Honduras, Prospera off Honduras, so forth and so on. There is a temptation to put both companies outside of reasonable jurisdictions. You say, well, we're a Cayman company, good luck coming after us, or to do medical experimentation in these kind of areas where there are purposely no regulation. And so I don't think, because unfortunately regulation is per jurisdiction, certain kinds of profit-making companies of a less ethical nature than the one Zoe works for will probably try to do this stuff. So what we want to do is we want to create a market where companies like OpenBCI who are using open standards that care about privacy and data can be kind of not disadvantaged against companies that are doing dangerous things or things against user consent. So it's not that we don't want to collect the data, because again, there are legitimate medical reasons for capturing the data, but you just don't want that data to be abused, and you need real consent, not like fake consent. You sign a TOS on Garmin and then or a watch and all your data goes to the Department of Defense of the US, right? So you don't want that situation. So I think there's going to be a combination of technical and regulatory regimes. I had some ideas on technical stuff. They may or may not be feasible because I'm not a super expert on BCI tech. Don't want brain data, neural data of any kind, which will probably be the next wave of wearables. I assume, I use wearables to track my heart, my sleep. Probably if there was a long time ago, I had a ear loss of hearing, and I had to use kind of non-invasive neural technology to get my hearing restored. I do think these kind of devices will be popular. They will have the potential for lots of medical good, but the danger is, because we exist under surveillance capitalism, that for better or for worse, there will be bad actors that will try to abuse this data. So it's in the interest of both governments, people, the users themselves, obviously, nonprofits, companies that want to do good things like OpenBCI, and academics to kind of join forces to try to prevent this bad behavior before it happens. Because if it does happen, it starts happening regularly, you will see technology which could otherwise have good uses just not be used, right? And that because people are afraid of it. And I think, while as a geek, I'm very excited by the concept of brain commons and learning from neural data and wearing these kinds of wearables. I might also be nervous, and normal people might freak out completely if they think, someone's going to try to control their mind, even if, as rightfully pointed out, that's very difficult with the current stats of technology. So I think we're close to time, unfortunately.
We are close to time. I think we can, given the technical difficulties, we can go about 5 minutes longer. Zoe, you got OpenBCI got name checked several times now in the previous comment. I'll let you have the final word, but I'd like to get a reaction from Christoph first, and then over to you. Christoph, I wonder if you have any reaction to what was said. Do you understand the concerns? Do you think people are worried too much, or just right? Or I don't know. I'm wondering if a sort of a universe with interoperable data controlled by users is beneficial as a thought experiment for you too.
Yeah, this is all correct. So very often in the press, it's overdone, what brain computer interfaces can do. It's not mind reading. It's not, you need status information what the BCI is doing. So you don't get that much information right away. Nevertheless, the EG data has to be controlled, and you just don't want to be acquired during the whole day and transmitted to whoever. So there should be regulations, and especially for all these developments and research projects that we are doing new, ethical guidelines are very important. So this ethical approval for all the research we are doing is very important. Not because I'm very concerned about the data that we are acquiring, but it must be super correct so that nobody can pinpoint you that you did something wrong. And of course, in future, we need regulations, how this data can be shared and what's allowed. And this will lead to much better and more applications. So a few years ago, we were, for example, in 54 medical applications. Now we have a couple of hundred medical applications that are done with g.tec devices. So it's just exploding for what people are using it. So regulations are very important.
Thanks so much. Zoe?
Yeah, I mean, I think Harry made a great point about kind of the things that we're seeing already in the wearable space that are making this more complicated. And I actually am at a conference this week, and we were just talking about how there's a new paper that recently came out that said, like, the sleep trackers on your watch and stuff, if it tells you that you had a bad night's sleep, you'll believe it, and then you'll act as if you did have a bad night's sleep. And so there's like a placebo effect that's happening there. And so things like that are definitely things that, we want to avoid as BCIs become more commonplace. And I do think that will happen. And even though the technology right now can't read our minds, I think, eventually I think it'll get to that point, just even though that's not the case currently. So I think it's good to have these conversations. And I think looking at what's happening in the wearable space is a good way for us to try to, make some decisions and think about how we can do it differently so we don't have these closed data standards that are happening now. Because yeah, I mean, I can look at my heart rate from this device, but I can't actually look at the PPG data that came off the device to, interpret for myself if I want to. And yeah, it's all just very close source. And I think that's something I would like to see different as BCIs become more consumer facing.
Thank you. Thanks. Yeah, I mean, those are the issues that I'm worried about as well. Like, even if the data can't say so much on its own, being able to investigate it, to be able to also to counter the claims of companies that say that they can read your mind, or that say that they can predict things that maybe you don't agree with or disagree with. Our next panel is going to be more about this topic. It's going to be about governance and openness of governance. I'd like to thank the panelists very much. Thank you for coming. Thanks for joining us and sharing your thoughts. And I will pass to Renata, who will moderate the next panel. Thank you.